Let's go through LeetCode 3102, minimize Manhattan distances. For this question, it gives us in two-dimensional array points, and each element is two size 2 array, which has x axis and y axis. For example, 3, 10, right? So the x-axis is 3 and the y-axis is 10. And it allows us to delete one point. And let's find the maximal to get the maximal the rest points, the maximal distance to be minimized. So for example, example 1, right? So there are several points, 3, 10. This is the point 1, and the 5, 15, right? The point 2, and 10 and 2, right? Point 3, and 4, 4.4, right? So there are these 4 points, and it says that we can remove 1 point, right? So so originally it may have the distance like for example 6 paths, right? So there are 6 different distances, and we find the maximum one, right? So after we remove one, for example, if we remove this, the rest point will be this, right? So there are 3 distance. So max distance will be 12, right? But if we remove this, the max distance is still this one, still very long, right? So if we remove this, the max distance is still long. So it asks us, if we remove one of the points, for the rest, what is the maximal distance? So for the Manhattan distance for 2 points, it has the distance equals absolute value x1 minus, for example, the axis is x1, y1, right? Distance between point x1, y1 to x2, y2, right? So it is minus x2 plus y1 minus y2, right? So for this kind of formula, there are 3 there are 4 in order to get rid of the absolute value, right? There are it changed to 4 different cases. That is x1. So there are four cases. That is x1 greater than x2, right? And y1 greater than y2. And this is case 1. Case 2 is x1 greater than x2, and y we can use for example greater equal, right? Greater equal to, and greater equal to x2, and y1 smaller than y2, right? Case 3 is x1 smaller than x2, and y1 greater equal to y2, right? And case 4 is x1 smaller than x2, and y1 smaller than y2, right? So if we discuss this kind of formula, 4 cases, so the distances has been translated to 4 cases to be have case 1, right? case one is x1 plus y1 minus x2 plus y2, right? This is case one. For case two, right? It is x1 minus x2 plus y2 minus y1, right? So it is x1 minus y1 minus x2 minus y2, right? For case three, it is x2 minus x1 plus y1 minus y2, right? So that will be x2 minus y2 minus x1 minus y1, right? And for the case four, it is actually x2 plus y2 minus x1 plus y1, right? So you will see the distance can only have the maximal distance can only be decided by two variables. We call variable, for example, the variable s sum, right? Sum variable, sum equals x plus y, and the d is diff variable, is x minus y. So the largest distance can only be decided by the largest sum variable or largest d variable, right? So what we're looking is largest s diff delta s and max O largest delta s and the largest delta d, right? So this is what what we are looking for, right? We are looking for looking to minimize, right? Minimize this one. So this is what we ask. So in this case, for every point, it can be right as x plus y and x minus y, right? So we want, what we want is it has a s variable and also a d variable. S is x plus y sum, right? And d is x minus y, right? So the maximal distance is for all the points the biggest difference among this, and the biggest difference among this, right? And we have a max delta one, this delta, right? And then this delta, and trying to minimize these values. So we know if so we know how can, if we have a point set, right? So if we have a point, for example, how can we calculate the maximal difference the maximal distance of this point if we do not delete any point, how to calculate the max distance in points, right? So based on what we analysis is that we do for every point, right, in points, we'll have so if we have a point set, right? How can we calculate the biggest the max distance is that we do for every point we have for example inter s equals p 0 plus p 1, right? Actually we can write this private int it max, right? So how can we calculate the maximal distance of this point sets is that we do for every point in points. We convert this point into two variables, right? Sum p0 plus p1, right? And the diff is p0 minus p1, right? So for example, we have so we need the so we can find the maximal of all of the points and the minimal of the points S, right? And also the maximal of the points D and the minimal of the points D. So the maximal can only be the maximal S minus the minimal S, or the maximal D minus minus minimal D, right? So let's say int S max equals D max equals so for every point, right? We can have the S max equals max dot max S max and S, right? And S min equals max dot min S min S, and S D max equals max dot max D max and D, right? And also D min equals max dot min D min and D, right? So the maximal distance is return max dot max S max minus S min and D max minus D min, right? So this is a formula how to, if we have a set of points, point array, how can we calculate the maximal distance between among those kind of points? So far, if we know this, right? And now let's let's just select one point and get the maximal, the rest of points, the maximal distance. So how can we select the one point? Okay, I will say this point can only because the maximal distance can only can only calculate, for example, the between the S max, this point, or and the S min, right? And also the D max, right? D max is actually here. D max and the D min, right? This is D max, and this is D min, right? Only these 4 points will decide our values, right? So we are from this kind of formula, we'll see that every point in the middle, if they are not equal to the S max or S min or D min or D max, they will not affect the maximal distance, right? So the maximal distance only being decided by 4 points. So our candidates to delete is these 4 points, one of these points, right? So if we delete this, right? So this kind of S max minus S min, they will be shrink. They may be smaller, right? So in this case, what we need is that we may also need to calculate the S second max, right? So if we delete this part, mesh get smaller. The same thing is that if we delete this, right? S min mesh get bigger, right? So we also need to get the second minimal one. The same thing about D max, right? D max, if we delete this, we need to get a D max 2, right? And also the D min 2, right? So intuitively, what's thinking about is that we need to calculate 8 values, right? So trying to delete S max and S min, trying to find the minimal of values of this, right? So it will be S max, for example, max 2. If we deleted S max 1, right? Then minus S min 1, right? And D max 1 minus D min 1, right? So there are 4 cases. But it's possible it is possible that it's possible that this S max and S max 1 or D min 1, they are the same point, right? So of course we can, when we calculate the max, S max 2, we can do some kind of calculations whether they for this point they have the same S max and S max 1 and D min 1, right? If they shrink to 1 point, we can use one for loop, but it will be a bit complicated. So what we think about is that we can firstly calculate 8 values S max 1, and the second S max 1, S max 2, S min 1, S min 2, right? And then we iterate for every point to see if they calculate the S max equals the X max, then it will be the that's second max, right? So that we're trying to delete one of the points, right? Just one of these 4 candidates. So after this analysis, we can write code for this. So we know now we need to have 4 variables. Int a equals points dot length, and int s max 1 equals IFRS. That is the sum of x and y, the maximum value, right? And s max 2 is the second largest. And also s min 1 will be the smallest x plus 1, right? And s min 2 will also be the second smallest x x plus p0 plus p01, right? And d max 1 equals f d max 2 equals d min 1 equals if, and d min 2 equals if, right? So initially we need to have 8 variables. And then what we do is that we need to, instead of calculate these 4 variables, right? We need to calculate 8 variables. So for every point in points, so let's say for this point we calculate its s variable, right? It's p0 plus p1, and for this point its d variable is p0 minus p1, right? So let's say if this s is greater than s max 1, right? Then we'll have s max 2 equals s max 1, and s max 1 equals s. Here, one of the things we need to take notice that we don't make this order to reversed. Right? Otherwise, s max 2 will also get s, right? So we'll get s max 2 to be x max 1 first, and say else if s greater than s max 2, right? Then we'll have s max 2 equals s, right? And for the mean, right? If s is smaller than s min 1, then s min 2 equals s min 1, and s min 1 equals s. Else, if s smaller than s min 2, right? We'll have s min 2 equals s, right? And also d, right? D have a similar formula, but we need to change this to d, right? If d greater than d max 1, then d max 2 equals d max 1 and d max 1 equals d. Else if d greater than d max 2, then d max 2 equals d. And if d is smaller than d min 1, then d min 2 equals d min 1, and d min 1 equals d. Else if d is smaller than d min 2, then d min 2 equals d, right? So that we calculate 8 point, second largest s variable, that is x plus 1. Second largest x plus 1, p0 plus p1, right? And minimal p0 plus p1. Second minimal p0 plus p1. And maximal p0 minus p1. And second maximal p0 minus p1, and minimal p0 minus p1, and second minimal p0 minus p1, right? Then we try to iterate the points, right? Trying to see if they equals, right? We try to delete one of the points. So now this p is so let's have a result. So every point, let's iterate the points, trying to delete that. So we'll say we try to delete this point, right? So if int skip s equals p0 plus p1, right? Int skip d equals p0 minus p1, right? So so for the rest part, what we need is that we have int s max equals, if this skip equals s max, right? S max 1, then our largest s max, we have to use s max 2, right? Otherwise, that is s max 1. And also s min, right? So int s min equals, if we skip the s, skip s, that is we are trying to delete this point, equals s min 1, right? If it is s min 1, then we are using s min 2, right? Otherwise, it is s min 1. And also int d max equals skip d equals d max 1, right? With d max 1, we have to use d max 2. Otherwise, we are using d max 1. And also int d min equals skip d equals d min 1, right? If it's d min 1, we have to use d min 2. Otherwise, use d min 1. So in the end, what we return is for every point, right? And actually, if does not relate to any min or max, we can skip that, right? Of course, you can write if skip s doesn't equal to s max or s min. Continue. For those points, it will not affect our results. but you have this calculation. It should be fine, right? So we can add, right? If we skip s does not equal to s max 1 and doesn't equal to s min 1, right? And skip d doesn't equal to d max 1 and if d doesn't equal to d min 1, right? If for this kind of case, if will not affect our result, we can continue, right? And only for those points, so actually only for those points which equals max will affect our results, right? So our result equals max dot mean result and our max. This is the max distance, right? So that is s max minus s mean and d max minus d mean. Right? In the end, we return result. Okay, so the time complexity for this is O(n) and the space complexity is O(1), right? Because we just use 8 variables to do the calculations, and actually for this one we calculate again, right? And we can also use write the Python code for this, right? Python instead of to calculate the maximum, right? Python has a very handful function called n largest and n smallest, right? So it can calculate s max or s max 1, s max 2, use this kind of function. We don't need to write our own, right? So we can also say if this kind of skip s does not equal to s max 1 and right, s keep s doesn't equal to s min 1 and skip d doesn't equal to d max 1 and skip d doesn't equal to d min 1, right? Then we continue. You can also add this kind of logic here, right? Continue is not defined. Tin sewing. Yeah, so we don't need to write it. So it help us to write those kind of largest and the second largest in those kind of function. It's also very, very helpful. Okay. Yeah, so this is for yesterday's contest, and this is my result.